Hopefully this is working, yes. Thank you. It's a great bow to you because you guys are the future, and it's my great pleasure to come here and meet you and hopefully influence you on to exciting new paths and an exciting new future. They asked me to say a little bit about myself, and I look back over my career and I realized when I was young and your age, the world was very stable. There were many opportunities. All I had to do was decide what I wanted to do and go work at it, and I had a good chance of being able to do that. Now, the world demands that you know more about science and technology because we've made big advances over the years since I was a young student. We've made tremendous advances in science and technology and in computer science. And as you can see, artificial intelligence does a pretty good job. I can talk, it shows up in English, and then it comes out in Chinese. We really have made it so that a big fraction of the world's economy depends on technology and on the development of the things that we got from early scientific research and then translated into technological developments and finally products that we use in our everyday life. And you're using them and you're just at the beginning phases. There's a big transition coming over the next 2 decades to where artificial intelligence will play a very bigger role in the universe, and you will not only be working to make that artificial intelligence better, but you will be working to be good partners with that artificial intelligence to make the world a better place. So I can give you advice, and one of my early advices was, finally, when I've gotten up and I won the Nobel Prize and was invited to go to different places and give an authors publishers at different universities, I thought, I can go to Asia where they respect people for their age. Well, you don't respect people for their age so much anymore because before that age gave wisdom and knowledge about the world, but now the world is changing a lot more. So I find that Asians don't respect aged people like me nearly as much as they used to, except that I got a prize. That helps. Actually, when I first started coming to China, I was more famous for being on a show called The Big Bang Theory. How many of you have ever seen The Big Bang Theory? No? No Sheldon? Nothing? You have. Before, everyone your age knew The Big Bang Theory. It's been off the air just for a few years, and now no one knows it, and so forth. But the other thing is, I noticed in Jeffrey's slide that not only did it get the Nobel Prize, but it got the Einstein Prize. I should have gotten the prize in chemistry for getting the stain out, right? Einstein. But the issue is there was a case back when I was young, about the time I got the prize, in which they called up a dry cleaner and told him he'd won the Nobel Prize because they didn't have the phone number for the chemist who'd actually won the prize, and so they called the guy with the same name who did really good dry cleaning. And there was debate in the press who should have gotten the prize, the chemist or the dry cleaner. Well, if he got the Einstein out, he probably should have gone to the cleaner. Now I'll tell you what I learned. The good thing is that when I was young, I had the opportunity for a good education. Some teachers that were quite good that encouraged me to go on. Some that weren't so good, but I somehow got past them. But I studied and I worked hard and I tried to learn the material. And I was more interested in learning than I was in the grades, and that showed up into my early stuff, although I usually got pretty good grades. But it was learning the subjects and learning the science that made me excited. I wanted to know how the world worked. Now, you learn the subjects and you learn the science because you want to be able to use your super smartphone and your connections to the rest of the world. And if you have a neural implant or whatever else is going to go on, you're going to want to have some knowledge and some understanding of how those things work. And some knowledge of what I call the culture of science, that is, understanding that science means there is an external world out there. It has simple rules and laws that it follows. And if you understand those, you understand a lot more about the world around you, and you can understand what are possible technologies and what are impossible technologies, and therefore what may be looming in your future to change your world. And so I think my experience applies some to you, but doesn't apply quite the same way because you're growing up in a different environment. Now, there are 7 billion people in the world. More than half of those people are connected to each other through the internet. And you collaborate or compete or do whatever is going on. But the world is different, but people aren't different. People are still the same basic genetic thing. It's only the cultural training and the experience you have. And so, as you're growing up, you're getting inspired here in the school. You're getting the opportunity to do things. My experience was having your hands on things and doing it was a much better way to learn than to try and just sit in the classroom and hear a lecture about it or something, or studying it. And so one of the things that I did later on was I made a big effort just in the subjects that I was really interested in, work all the homework problems. So I knew I really understood that subject. Because to me, it wasn't the grade as much it was truly mastering the material and understanding that I really knew what the field was or saw what some problems were. And so it's a different kind of world now because there's more information out there than you can possibly learn by yourself. That's why you're going to have your AI mentor, you're going to have an AI partner in life, an avatar or something, who's going to be digesting all that kind of information for you and feeding to you the stuff that's really important for you to know and understand, or giving you reviews when those particular things come up. And so part of what you're learning is going to be over the next 20 years is how to work with AI and have a good avatar to make your interface to the rest of the world clean and smooth. I maybe talked a little too much. I should ask you, give you opportunities for questions or for one, what do you want to know or what you want me to tell you about that would make things different. Because, when we were babies, we weren't different. It's only the period we grew up in that makes us somewhat different, and the choices that we made in our lives that make us somewhat different. Here, you're doing the same thing. So, do we have some questions from the audience? Okay, so this is a meta question, but what that means is it's a more generic thing. The meta-universe is only part of the real universe. You have to remember there really is a physical universe, and there really is a biological universe, and there's the meta-universe where people are going to get together on a social way to do things, and maybe even a working way, interpersonal relations. Because as AI gets more powerful and robotics becomes more common, the positions and things for humans to do is going to be a reduced space or going to be expanding into places like the meta-universe. And so you have to think, how am I going to exist on 3 possible levels? Right? The real physical world and the biological world and the social and work world. And you have to maintain your own self-worth in all of those. That is, every person has to be behaving and working and interacting in a way that they consider honorable and so forth. You can go back to Confucius or to other, Chinese philosophers. They tell you what it takes to be a good person and what it takes to be ethical and to be reasonable in your behavior. And not everybody is going to be that way, but it's up to you as an individual to behave in such a way. But you still are going to have to go where the human interactions are, or the human-machine interactions are, to do your work and to do your social activities. And so it's just like we had before. Before people lived in the village, and you had to go down to the market and bargain in the market and do like I said. That was the plane where you had to have your social and other interactions plus having your own family. But you had to work in the farm and the fields, or you had to do work in building pottery and things like that. Those kind of things aren't going to change so dramatically, but you don't have to think I have to shine in this area. I mean, one of the things that I see when I go to tourist spots is I see people taking TikTok videos or beautiful pictures to put up on their website. They want people to think they're living a wonderful life. Well, they're so busy taking the pictures and so what they didn't even enjoy the sight. And so you have to be careful about being a real, authentic person and keep your integrity together. That's the most important thing that you can do. Because in the end, it's how people interact and how the world cooperates that's going to make things work. So the answer is, I have been worried about climate change for more than a decade.
Yes.
I've been working on it. I actually came originally to Hong Kong for a meeting about what cities could do, because cities are the big effect in these kind of phenomena. What cities could do to help ameliorate it, because countries were saying they're doing things, but then they weren't actually doing major things. The European countries have kind of made some changes, but North America, South America, and most of Asia have not, including China. And I was advisor for China, and in the early days when we had the reviews, there would be people saying, we've got to get more energy for the population. Everybody likes the energy, everybody likes the lights, everybody likes the street lights at night, everybody likes everything. And we need to run our industries, China was building more and more energy, basically electrical energy resources, but many more energy resources. And there would be occasional talk about what the climate change was. Then later on it became, those reviews would be climate change and the energy. And the first 3 days, or 2.5 days, would be talk about how bad the climate effect's going to be. And the second 2 days would be about how we're going to get more energy sources because people demand. I mean, the air conditioning is on here, right? You like electricity, it's very handy. And so the issue that we have is society likes the advantages they can have from the energy. And most of the energy in the world today is still coming from the hydrocarbons, gas and coal and oil and so forth. And only a small part is coming from renewables. And it's growing, and we can hope it'll grow more and more. You see, when you look out here, you don't see so many windmills, but you do see solar cells and so forth here in Hainan. And that's relevance to it. But if you look, even at the last review that I went to, they're still trying to build more power because guess what? Last year, China used 5% more electricity than they predicted they were going to. And the reason was, it was warmer, people ran more air conditioners, and there were floods in every major city, and they had to run more pumps. But it really was the heat. So the answer is, there is climate change going on. We have been promising since before the Paris Accords, although before that it was really hand-waving, the Paris Accord was real promises by countries that they would exceed that. But the fact is, all the countries are pretty much exceeding the kind of goals that you want to have in order to make the temperature rise of the Earth be less than 1.5 degrees Celsius. In fact, we're almost there already because the UN rules is that it has to be several years in a row, and then you're above that. And so we are going to see big effects from climate change. You might have noticed here in Hainan that a typhoon came through here earlier this month, last month, and it was a bigger storm than normal. So what you see is when the Earth is warmer, and particularly when the water is warmer, typhoons will be more powerful, right? So I used to come to teach in Hong Kong at the beginning of the semester, which was the beginning of September. Almost every year that I came there would be a typhoon that first week of September, and occasionally it did damage to Hong Kong, but Hong Kong's a little more protected, and Shenzhen, which is kind of low-lying. And then this last year, all the way up to Guangzhou, there was significant. So we can expect, particularly in the United States, because the storms are Africa, cross over the Atlantic, they get to the Caribbean, the lower the United States, and that is very much warmer than it used to be. That provides more energy for the winds to go around. And so you've just seen we've had 2 big hurricanes in a row in the last month that caused significant damage and deaths. I mean, there were more than 200 people died in the first hurricane. So the answer is we are seeing global warming effects or climate change effects. And we were seeing that more at northern and very southern latitudes, although there's not so much stuff in southern latitudes. But in the northern latitudes, there's more. We're worried about things like northern Russia, the tundra in northern Russia, getting to where it's actually quit being frozen, and releases more gases, but also releases some of the bacteria and viruses that have been frozen in the tundra for hundreds of years. And so we're going to see a number of big effects. It's going to affect crops worldwide. It's going to affect, the weather systems worldwide. It's going to affect places like to the very much more west of here. That whole area is very dry and very hot. When things get very dry and very hot, there are more wars. There are more wars because people are grumpy because it's hot, but also because they don't have enough water, they don't have enough other resources. So it is going to have a major impact on the world, and we're going to have to do the best we can to try and improve that. And so in Hainan, they're making certain efforts, but the fact is, you want Hainan's climate not to change too much. You don't want the ocean to get too much better, because you have a certain amount of animals and plants that grow only here, and you like to preserve those. But it's true, but there's a risk to major parts of China from the droughts, and also from the air pollution from the fact that so many hydrocarbons are being burned. And so it's an issue that is a worldwide global issue. It's still being decided by almost 200 countries separately, but in fact it's a worldwide problem, and so it has to be a group of everyone in the world getting behind that. And if you live in one of those small, Pacific island chains, well, unfortunately, it's already too late. I mean, the ocean is going to expand. If you study physics, you realize that when the temperature changes, things expand. But most things, if you heat them a little bit, they get a little bigger. That's how the old-fashioned thermometers work, and so forth. But if you heat water, it will expand, and the ocean will get to be taller. And you can figure it out. We already baked in 1.5 degrees. The temperature of the oceans takes a while to turn over, but it's going to get 1.5 degrees warmer. That means it's going to expand by 10⁻⁴, but it's 2 kilometers deep. So that means it's going to come up that much higher. Well, that doesn't seem like much. You live in Shanghai, that's a lot. Because the first typhoon that comes through, you're going to flood over 40, 50 million people. I mean, it's a very serious. So these are extraordinarily serious issues for the future. We're just seeing it ramp up. And the bad thing is we're used to things going linearly. This is going to go up like that. So the answer is yes. Climate change is a serious problem, and it's going to affect us in many ways. It's going to affect some crops. I mean, we run a risk of not being able to get bananas or something. Depends on what happens. So some of the crops are relatively narrow kind of latitude, and we'll find out what happens because we're running the experiment. I mean, this is physics. We try and work stuff out theoretically and in computer simulations. We prefer not to do the actual experiment until we have a good control. Here's an experiment we're doing on the human race and the Earth, and it's going to have an impact. And we've already seen more than half the animal species have been wiped out. We're going to see that in the number of the plant species too, and we're going to see a lot of humans suffer quite severely. Thank you. Okay, so the question is about recommending books. I haven't been reading as many books lately as I have been reading articles and opinion pieces, studies by experts in the field, because I'm trying to keep up on what's happening and other things. However, you can go online and ask for recommendations for books, with the AI systems or with colleagues, and ask for books in the areas you want. I get in my email, because I looked up certain topics and certain books, I get recommended books automatically by the quasi-AI systems that Amazon and Google run. Are you interested in the human stories about how people became great scientists and leaders, or if you want to learn about how do I get up to date in the field and learn what's going on. And the problem with a lot of physics and chemistry, and now getting to be true in biology, you need to do a lot of groundwork. You need to do a lot of the basic courses, the basic studying, so that you understand the foundations, and then you can move up to the more advanced levels. And so we actually have been making progress in science. And we've studied stuff. I mean, I look back, and when I'm in Paris, and sometimes I go to the old great schools, and they have preserved Louis Pasteur's old office. And I went in, and I sat at the desk, and I got a picture taken, and I sent it to my college roommate, and he said, "That's really great." He was so advanced, he had because they had just saved the office, and the telephone didn't come for 50 years. He said he was able to get work done because he didn't use the telephone. Nobody else had a telephone for 50 years. But the fact is, he discovered that disease and so forth was caused by organisms, and led to pasteurization, led to a lot of other stuff. An example of a great scientist, but it's a different kind of approach, because now we have things to understand about that. So you can read like the life history of Pasteur or Marie Curie and so forth, and that will teach you something about their personalities and about what they did. But the question is, do you want to learn about the person, or do you want to learn about the subject? You've got to get a good foundation here, but there are some popular books that will give you enough information to give you a background on what's going on. So you have to figure out what is it you're interested in, what you want to study up on, and you can do that. Thank you for this question, except that it shows that you're very worried about the ecological and climate changes that are coming. But Earth is so much better for humans than anything that we've seen. It's really a difficult thing to think. Would you like to spend the rest of your life on a moon base? And the answer should be, it'd be fun to visit for a week, but I don't think I would want to be there for 10 years, right? So the answer is, you'd much rather be in Hainan than you'd rather be in a tunnel on the moon. So that's the first part, is the environmental hostility, the fact that humans are actually a collection of organisms, but in fact they're part of a collection of an ecosystem, which we're doing some damage to. But it's still much nicer here on the Earth. You look out your window here and see the palm trees and see all that. It's just a beautiful place, and you can't but feel better when you do that. Now let's talk about going to another planet. The nearest non-solar system planet, near Alpha Centauri, which is 4.2 light years away. And I won't say no sweat. I can be frozen for 4.2 years and go there at the speed of light. But you can't go at the speed of light because there is hydrogen gas, there's other stuff out. If you try and go too fast, you're likely to run into something that damages your rocket ship so bad you don't make it. And it's also very expensive to send you there, because you'd have to have oxygen and food and water and so forth. So you'd have to freeze you. But if you're going to do that, a smarter thing would be to take, human embryos, just freshly fertilized eggs, frozen, and then put robot caretakers or nannies to take care of them, and keep them frozen all the way to that thing, and then have the robot nannies raise them on the other side. Even that's kind of expensive. You might as well just send robots. That'll be the stuff. That no one here on this Earth will ever make it to a planet outside of the solar system. There's almost when you start putting the numbers in of how much energy it would cost, it would basically cost to send a group of 20 colonists or something. It would basically cost the entire energy supply of the Earth for 20 years to be able to send that one group to be a colony, and you don't even know if those planets are habitable. There are some projects going on now to try and send microscopic little satellites out to beam back a picture of those planets to see whether it's reasonable or not. But if you think about what's the best way, and so one of the people who's doing it is funding it, some billionaires are funding that, and they want it to come back with the information in their lifetime. And my comment when I did the studies and wrote an article, it's much better they spend half their money on life extension so you could go at half the speed. Because even if you go at the 10th the speed of light, if you use high power lasers and blast these things out to the 10th the speed of light, they still have a good chance of running this up and getting smacked. If they were going a factor 2 slower, they would then have a better chance of making it, even though instead of taking 40 years, it would take 80 years to get there, and then 4 years to get the light signal back. And so there is no way anyone in this room is going to go to another extrasolar system planet unless you guys all get together and work on a biology problem of making people's lives extremely long. If you can get people to live thousands of years, then you can do it. But remember, you got to live through thousands of years of the Earth climate changing and stuff like that. So there's no, evading the issue. Humans have to solve the problem of climate ecosystem issues. We got to be able to continue living here on the Earth. So thank you for that question. Let's go to the question. So physics is hard. Just like almost every other part of human knowledge is hard now, because we've made advances in many fields. So one of the things that I did was go into a field that almost no one was in. The issue is we have made progress in physics. I go to the physics lab, they're doing an experiment that Newton provided the basic information for, and did similar kind of experiments that showed right. It was Galileo that I see closer thing. Physics is hard because it's based on a solid foundation and a worldview. The worldview is that there's an external world and it has simple rules that it follows, and competent observers will agree on that. If you believe you can change things with your mind, that makes life a lot more complicated because you've got 7 billion people changing things with their minds. But in physics, you have this solid foundation that there is an external reality. This external reality obeys a set of simple rules. We think of 4 fundamental forces, certain other symmetry structures for the basic particles, and all this kind of stuff. It's actually built up over many years, over many decades, since the 1700s up till 2000s. We have been building and understanding and making it better, and understanding how from these simple rules we can also have second order things appear on the surface of that once you've made this beautiful platform, you can have second order effects that end up in showing up more complicated systems that shows up in as metaphysics. Eventually, you're going to be having multiple, not just LEDs, but multiple products that take advantage of the fact that there are excited states of things that are relatively stable and can be controlled. And so, to learn the physics, you have to do the work. That's the bad news. You got to learn the physics. It's like learning the math. You got to learn the addition tables and the multiplication tables and so forth, or you got to learn to have a machine that tells you the answer. And so to learn physics, you got to start learning it, and you got to get the foundation right. In college, we start with recap of high school physics, and we introduce new topics. The first semester is a review, but better. The only thing that usually gets thrown in is rotation, rotating devices too, but some high schools have that. And then we go into thermal physics and the electromagnetism and things like that. So there's a first level that things are introduced. There's a second level as you get into the junior and senior level, the third and fourth year of college. And then in graduate school, you go through it again, and then you're finally to the frontier. And it was always a shock to the students. They come to me and they said, this paper that just got published, I think it's wrong. And the answer is yes. Sometimes things that are not right get published in the preprint servers, and you know, it's up to the community to review it and see which ones should get accepted. Well, we have been building on physics now, basically since Galileo's time, and we've been building it and evolving it, and it hasn't stayed static. It's not like a high school history course where you're reading about the Romans and the Greeks. It hasn't changed. Well, it has changed because we've dug up more materials and stuff on the Greeks and the Romans. But the fact is, what happened there didn't change, and the history didn't change. It's our understanding of it and the backup information. But in the sciences, in physics particularly, but in chemistry and now in biology, we're making advances and we're going further. So the only way to understand physics is to study it, do the groundwork, learn what it is. It's just like walking. You don't just jump off the crib and start walking here. You have to learn how to walk, and you have to learn the motions of the body. And so you're learning a certain amount of physics there. But here, physics has gotten much more advanced because of virtually people like me and the people that came after me. People are making advances, and it's great. That's what's exciting about the field, is that you understand things now that we didn't understand before. But for students, the bad news is you got to study, and you got to do the homework problems, and you got to learn to think about it. I mean, I always did the homework problems, but I also tried to see and understand it at least two ways. Look at it from this side and understand it, and you get the answer, and then look at it from this side, right, and understand it to the answer. In physics and in the other sciences, usually more than one description of how a thing works should work properly and give you the same answer. Because it's not the formulas, it's what actually happens is the thing that you're trying to produce. So the bad news is you got to do the work. Some of my colleagues, I don't know if you knew the Drake equation or Drake was involved. We had a system where we're worried about how do we hand down from the older generation to a younger generation, continued study in the search for aliens. And that was because the government agencies in the United States decided not to fund that anymore. We were worried about it. Now it turns out some private citizens who were quite wealthy from social media, have investing in a place, Facebook and things like that, have put money up to continue those kind of searches. So we didn't have to worry. What we have to worry about is the quality of the plan. But I had this discussion with people several times about, are there aliens? How come, aren't there aliens in the skies? Aren't there aliens under the seas and so forth? And my comment was, if I sit back and look at the broader view of aliens, my first question is, why would any aliens come to visit the Earth? What's so important about the Earth that aliens should visit it? What is so important about humans that anybody would want to meet it? Just like you want to meet the ants in the southern part of Hainan Island, right? It's a question about, right, should the aliens come here? But the question about, should there be aliens out in the universe, that's a more interesting question. You can ask, how many planets are there out there? And there is basically more than one planet per Chinese person out in our own galaxy, and that are in the habitable zone. So if we want life that's like us, kind of carbon-based, fluid-flowing kind of material, there's plenty of sites. But in fact, there are billions of galaxies. So how many aliens should there be in our own galaxy versus how many should there be in faraway galaxies that don't matter to us because we're never going to get that far? And the answer depends on how optimistic or pessimistic you are. We see that life formed the Earth almost as early as it could. Is that because in order to get to intelligent life today, you had to start way back when? Or is that because life pretty much starts up anywhere and it should be everywhere? And because there are planetary systems that are significantly older than the Earth-Sun system, then there should be some advanced societies. And that adds up to the big question that was known as the Fermi question, which is, if there are aliens, where are they? Why aren't they here? Right? Because if you get to a level 2 to 3 civilization, or a level 0.8 civilization, you should be capable of sending out probes to other planetary systems and then having them build factories and generate more probes. And you pretty much propagate across the galaxy at near the speed of light. So one of the answers is there a bottleneck that stops civilizations from getting further? But they get so stupid and so successful that they climate change their existence to zero. And, well, we'll see. We're running a test. But the fact is, I think it's extremely likely there are other alien civilizations out in the universe, but the universe is a really big place. We had a question about why don't we go to some nearby Earth-like planet? And, well, it takes a long time. If you went on a 747, an airplane to the moon, it would take you, more than a week. The moon shots that the U.S. and China are doing, they take several days. The moon is so close, it looks like if you look at the solar system from far away, you can't even see the Earth, moon. The Earth itself is a tiny dot. The sun is pretty small on that scale. And so when you think about what's the likelihood, what's going to happen, we don't know. My opinion is that a lot of the civilizations may have changed to where their AI run and no longer carbon-based, they're silicon or some other base. You don't know for sure what you're looking for in aliens, but you also don't know why those aliens are trying to get in contact with us. Some of my colleagues look for alien signatures, that is, societies that got so advanced that they're blocking a lot of the light from their sun because they can get the solar power or the sun power to be able to run their civilization, or putting around black holes and using a heat pump thing where you drop your garbage in the black hole and get energy back up. And there are lots of kind of things you can think about, but you would think that it's more complicated unless you've got the idea of the black forest, the dark forest, that there are some bad aliens out there, and if you're an alien group, you don't let anybody know you're around because those bad aliens are going to come and kill you. Right? There's lots of possibilities for what the universe might be like, and you can make reasonable arguments for why there could be some bad aliens. And so it's not at all a crazy question, but it is a question that's way more complicated. And though we have a lot of progress, we'll see, we're going to, in the next 20 years, have enough satellite information to see if there are forms of life on other planets. Maybe not advanced civilizations, but at least forms of life where there is some planetary stuff going on. So it's a very interesting field, but we're not quite to the point where we can make solid decisions about it. So thank you. Thank you. That's a very good question. And some of my physics colleagues were arguing about that some years ago for the AlphaGo team, which won half of a Nobel Prize in chemistry this year, that they should get awarded because the advance is so good for humankind that they were able to figure out how to fold all the not all the proteins, but 60-something of the proteins that we do every day, and then could do medical research. So the answer is, Physics Nobel Prize was given for basically developing the model of the deep neural net and deep learning. And that is going to have a tremendous impact on the life sciences and biology. And it's because the life sciences and biology are very complicated, but we're now getting to the point where we can probe down on the molecular level and understand what's going on. So it's a huge data set, and many, many topics, thousands of things go one side of the cell, whereas in the universe, on a big scale, only a few hundred things happen, and most of them are in equilibrium, we can understand them well. And so it's going to have a huge impact on the life sciences, but it already has an impact in some of the other sciences. It's just the life sciences are just a very rich lifeblood kind of a situation for applying that, and particularly in the medical and biological sciences. So I think that it was a physics prize, but its impact could be greater than that. But you know, in the long run, physics and chemistry and biology are not going to be separate fields. They're all going to fit together. So thank you very much for your... You get the last prize. It's the last one.